For introduction, we will go through in general about the bamboo itself and the problem of our research, objective, and so on. Day by day, the construction industry was developed well as we are a step closer to be a developed country, so we must give priority to the sustainable construction to keep our environment safe. This research focuses on reducing the non-renewable resource and increasing the renewable resource, which is bamboo. These are some properties of cemented bamboo which produce a good fiber bonding, produce high value-added product, high strength, and so on. The problem that inspired us to do this research is because of high cost in building construction as it using the non-renewable resource. So we decide to replace the non-renewable resource with eco-friendly materials, specifically the cemented bamboo. Based on the data from CIDB, the price of sand per ton increased year by year from 2013 to 2015, and for sure 2021 will be higher. Okay, the objective of our research is to investigate the strength performance of the concrete with based on the replacement of fine aggregate with the SBF, and we need to determine the optimal percentage of SBF and compare it to the previous research. For the scope and limitation, we are using the bamboo fiber to replace the fine aggregate in concrete, and the bamboo used in this study is cemented bamboo, and the fiber is untreated, and we also compared to the other research as a validation for the data. Why this research is so important? The first one is to help the contractor or the construction company to use this innovation, and the second one is to find the optimal percentage of fiber used which give the best result, and also to promote the sustainable construction, and the outcome for this research will become beneficial to the future research. A bit of a summary for the literature review. This is the list of papers that we refer to in order to complete our research. This is the analysis of the topics that has been discussed in the papers that we refer to.
Assalamualaikum, my name is Faridun Shah and I will continue with the methodology part. So this is our experimental step. First, we prepare all the material that we use in this experiment and continue with the concrete mix process. Then we proceed with the test on every specimen and compare the result with standard cube block and other different results from other research. Lastly, we will go to the result analysis. For the experimental properties, we use ordinary Portland cement grade 43, coarse aggregate with nominal dimension of 20 mm, fire aggregate which is sand, and bamboo fiber SBF that we extract from raw cemented bamboo. For SBF extraction process, we prepare 1000 mm bamboo stick and immerse it in water for 24 hours. Then the bamboo will be crushed in the fiber extraction machine to get the fibers shape. After that, the bamboo is combed to remove the bamboo knot and epidermis. Next, wash the fibers and let it dry in the room temperature. Lastly, after the fibers are dry, cut it into 2 cm long and it is ready to use. For concrete cube process, mix all the material that we prepare and put it into the concrete mold and let it dry for 24 hours. Then took out the concrete from the mold, label and put it in the water for curing process. After the curing process, we proceed with the test on compressive strength. These are the concrete mix design that we use for every different percentage of SBF we use. And these are the tests that we did on our sample to get the result, which consists of slump test, density test, water oxidation test, and compressive strength test.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazri bin Shahrul Nizam. Next, I will explain our result and discussion. The following is the result for slump test. For 0% replacement is shear slump, and 5% replacement is true slump. Meanwhile, for 10 to 20% is zero slump. Zero slump occurs when the SBF are naturally dry and capable for absorbing the water, as SBF are uncooled, so the workability for this percent is poor respectively. For the next tests such as density, water absorption, and comprehensive strength, the result will be compared between SBF and coconut fiber after 7 days of curing from previous research. The result for density comparison have found similarities between SBF and coconut fiber. This is because the density value has decreased as the percentage of fiber has increased. For water absorption result, this comparison have found difference between SBF and coconut fiber. The water absorption value for SBF has decreased as the percentage of fiber has increased, and otherwise for coconut fiber. For comprehensive strength result, if the percent of fiber content was increased, then it reaches its optimum value, makes the mixing procedure more compatible and workable. In this comparison, the optimum percent of SBF is 5% while coconut fiber is 9%. So, the comprehensive strength value will decrease when the percentage of fiber exceeds the optimum value. The study also compared the comprehensive value for SBF between 7 days and 20x days after curing. The expected strength for 20x days after curing were calculated by using ratio method, where the result of comprehensive strength value after 7 days was assumed 65% of 20x days result, which is 100% of concrete strength. It was observed that this comparison have found similarities between 7 days and 20x days after curing, which is 5% of SBF will produce the highest comprehensive strength and 10% of SBF will produce the lowest comprehensive strength. So, the value of comprehensive strength will decrease when the percentage of fiber exceed the optimum value. That's all from me. Thank you.
To conclude with, we have achieved the objective, which is to test the performance of concrete with SPF and to determine the optimal percentage fiber used. And from this experiment, 5% give the best result and some recommendations were identified for the future researcher. First, use a small percentage in range 3 to 50% to determine the optimal value. And second one is use proper treatment for the bamboo fiber, specifically use epoxy for the treatment. Thank you. That's all from us, and thank you again for spending your time.